All right, the last technique in the carbon NMR is called DEPT. DEPT is the DEPT stand for right here, long name, distortionless, enhanced polarization transfer. Oh my God, I don't even know what it's called. So I just call it DEPT, right? DEPT carbon NMR. So DEPT carbon NMR works like this. Okay, we're not gonna get to the detail how we get to depth or the theory behind it. We're just gonna look at how we use it. Okay, all right. So depth have a 3 spectral scan. Number one scan the first time. Number one scan, the first scan is the broadband decoupled scan, which is a regular carbon NMR. So for example, this molecule 1, 2, 3, 4 carbon, 4 different signals, just like normal in carbon NMR. Okay, the second scan is depth 90. 90 is a 90 degree. I don't know what's 90 degree of what, but that doesn't matter. Anyway, the good thing of using depth 90, depth 90 shows only a CH. One peak right there. There's only one CH, show one peak. You know? And the third scan is depth 135. Depth 135 is good to look for a CH2. Here's what happened. In depth 135, the third scan, any carbon signal that come from CH3 and CH point up, and any signal from CH2 point down, positive signal and negative signal, and we know exactly which one is CH2. Okay, only thing that depth is doesn't work with is a quaternary carbon. The carbon that have 4 carbons around it do not show up on depth. Okay, and here's how it works. Take a look. Let's say if you have a regular carbon NMR and depth, so we have depth 90 and depth 135. These are 90 and 135. These are degree, but of something I don't know. Anywho, so we got all right. Now, if you this depth experiment help you match carbon to the spectrum. Okay, let's take a look. For sure, that's a C. All right. How do I know? Well, it's on region number 4 below 200. That's ketone. Ketone aldehyde usually come up above 200 ppm, but because of resonance, go below 200. Okay, and it's a quaternary carbon. Depth doesn't show quaternary carbon, so nope, nothing there. Nothing on here, nothing on here. All right, so that's C for sure. Now, next one, so A and B are sp2 carbons. All right, so sp2 carbon on region about 150, below around right here. There's 2. I mean, about 120, so right here. Which one though? If you remember the trend, so B a CH, right? A a CH2, so B should be more D-shielded. So you can guess that, hey, that might be a B on the left side, on the left signal, on the right side gonna be an A. But depth is really actually confirmed that. Take a look here. B is a CH, right? Depth 90 shows only a CH, right? Any signal from CH is show up right there. That's totally a B. Okay, and depth 135 show CH3 and CH are positive signals, so that's a B. And guess what? The other one for sure is an A. Did you know why though? A is a CH2, right? CH2 in depth 90 doesn't show up, nothing there. And on depth 135, CH2 is a negative signal. That's totally an A. Yeah, depth helps so much to like pinpoint like which carbon is which signal. Really helpful. And last one is the regular CH3 right here. Depth 90 doesn't show CH3, so nothing there. And depth 135, CH3 is a positive signal right there. CH3. There we go. All right, I'm going to have you do this on your own. Okay, and then check with me. So you have to match this carbon to the spectrum. All right, what we get here. For sure, above 140, 150, 160, 170, below 200, that's region number 4, carbonyl carbon, B for sure. And no signal up here, depth 90, depth 135, so that's a B. Carbonyl carbon. Okay. All right, the next one, let's say above 60, that's going to be next to the oxygen, I'm pretty sure. The one below 40 ppm, that's hard to say. But guess what? On depth 135, say that these 2 signals are from CH2 because they both are negative signal. You know? So looking for CH2, we have C and D. These 2 are just CH2, right? And what else? So one is more D-shielded, about 60 ppm, totally going to be C. Okay, the other one going to be D. Yeah, depth is really helpful. Yeah. Next one, what we get here, probably combination of CH and CH3. I don't know what's going on there, right? But let's so we have A, E, and F left, right? CH3, CH, and CH3. Which one is E though? Totally, that's an E. Depth 90, right? Only CH shows up, right? So that's an E. Now the rest is gonna be A and F. Okay. So well, this one is hard to say. So some of you might think so A is an alpha carbon, so A should be more shielded, and the other one's F, but this is really hard to say. They overlap in here. Okay. A and F, that doesn't matter. So you can do this one A, this one F, something like that. All right. Okay. Let's try. So I want you to try this on your own. All right. I will then check with me on the next video.